Okay, Math 8, we're going to do lines of best fit. And right after that, I'm going to do this video. We're not going to have a video for this one because it's interleaved practice. And hey, that'll be it. Okay, so then you'll have all the videos. Don't have to wait if you don't want to. Describing trends in scatter plots. Okay, so we talked about scatter plots last week, and there they are. And so we want to describe the trend. So looking here, this is years since 1970 on the x-axis, and that's our explanatory variable. And the response variable is number of hurricanes. So does kind of look like they're increasing a little bit. You know, there's some high numbers over here that are not over here, but it's not very clear. So on the test, I would accept A or C as long as you gave your reasoning. Also, this is the same, but yeah, I'm gonna say there's no clear relationship. I'm gonna say it increased, but not really that much. So I would accept either one as long as you provided reasoning. I mean, it did increase. Okay, so this is a better pattern here. We can see this is a non-linear association. It goes down and then back up, right? But we can see the pattern. So the amount of fuel was lowest at speeds around 60. Is this 60? Yeah, and then fuel used is on the y-axis. So at this point, they used the least fuel. So we're using the scatter plot and, we're describing the trends. Okay, now this one is definitely a decrease, right? I'm looking at the dots and they're high on the left and low on the right, decreasing. What does it represent? Average number of buses per hour, average or number of complaints. So the less buses per hour, the more complaints. That makes sense. People get cranky when they're waiting for the bus. So there tended to be more complaints on days with more buses. No, on days with less buses, there was, when the X value was lower, there was more complaints. Fewer complaints on days with more buses. There we go. All right, so have fun with that one. If you make a mistake, it's all right. I did. Just figure it out, put it in the organizer. Estimating slope of line of best fit. So there we are. We have our scatter plot, and we can make a little line of best fit, and then we're just going to estimate the slope. So exam 2, exam 1. Yeah. So what I'm going to do here is I'm going to draw a line, and the line of best fit is the line that doesn't have to go through the most dots, but it's closest to the most dots. And so we can see this line, if we pick 2 points on it, then it's kind of, it's like the 10, 10, 20, 20. This line almost has a slope of 1. So I see 1 there. All right. So I'm just drawing my line of best fit, and then I'm estimating the slope. Let me do a better job showing you on this one. So this time I'm going to pick out 2 points. So there's my line of best fit. You can use the scribble tool to find yours. So now let's search for 2 points. So I see it goes to 1, 2. And it also goes to this point. It goes through 2. At 2, it goes to almost 5. Not really, but I'm just going to say 5, and then I know it'll be a little bit less. So change in x is 1, change in y is 3. So it's about 3 over 1. It's about 3, maybe a little less. And so a little less than 3 is 2.5. There we go. Okay, so you're going to draw your line, find 2 points on the line, find the slope, and then you'll have your approximate answer and see which one is the closest. Estimating equations of lines of best fit and using them to make predictions. Okay. So, and I encourage you to read through the scenario. I'm just trying to show you the mechanics of the assignment. And also we're looking at the axes, and that gives us information about what the scenario is. So hours online, mood rating, and I saw Jacob, right? So Jacob is measuring his mood based on the number of hours he spends online. Interesting. We all like doing things on the internet and our phones and whatnot, but the more time you spend, look at Jacob's mood actually went down. Should tell you to get outside, right? So we're going to find the equation, and then we're going to substitute 5.5 our explanatory variable, and then figure out what the mood rating will be. So let's find 2 points. So I find this point right here, 2, 6, no, 2, 5.5 is 1 point, and what's another point right here? 3.54. Okay, so there's my 2 points, and from those 2 points, I can find the slope. I'm also noticing the y-intercept is 7.5. Okay, so I almost have my slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And now, if that's 7.5, we know that b is 7.5. We're going to find the slope right quick. The change in x is 1.5. The change in y is negative 1.5 from 5.5 to 4. So a rise over run would be negative 1.5 over 1.5, which is negative 1. So our slope is negative 1. So now we have our equation, negative 1x plus 7.5. And I see that exactly. Look at that. All right, so then, if that's the equation, then we can substitute 5.5 into it and figure out the mood rating after 5.5 hours online. So negative 5.5 plus 7.5. So what, add those together, what is that? That's 2 and negative, that's 2. So his mood rating would be 2 on a scale of 1 to 10. Not very happy. All right, so there you go. That is the line of best fit. Lines of best fit are so powerful for making predictions. If you remember machine learning math with my brother in the fall, maybe I'll put that right down here. He talked about using lines of best fit, and it got him a promotion at work. All right. So do a good job.